7.6 has us working with quadratic equations, and based on the fact that it's in Chapter 7 and we've been doing a lot of factoring up till now, we're going to be learning how to solve these quadratic equations using factoring. All of our previously learned methods are going to be showing up here, or at the very least they are eligible to be showing up here. So we might be using one more consistently than the other, we might not use one as often, but all of them are fair game and perfectly eligible to be showing up in these problems. Now, to get started with this, there is one specific property that we do need to make note of before we get started and in working through our process, and that's the zero product property that we have right here. The zero product property states that if we have A times B equal to 0, then that tells us that either A or B are equal to 0, or both of them are equal to 0. And we can think of this as essentially being, if you have two numbers multiplying together, and the result is 0, well, one of those two numbers therefore has to be 0. Could be the first one, could be the second one, it could be both of them, but at least one of those values has to be 0. So we're going to be using that later on when we fully factor everything out to basically break these things down into two things multiplying together, or maybe in some instances, three things multiplying together, or four, or however many are listed in there. But if everything is multiplying together, and the result is 0, then that means one of those things that's multiplying together has to be equal to 0 as well. The whole thing is going to result in 0. So this is the background property that's taking place and allowing us to go through and have the process that we're going to go through here and get to our answer. So if you're going to be taking notes on this and writing anything down for yourself, I'm going to highlight the specific steps that I would recommend noting down for yourself in your own notebook or anything like that. So we have our process here. I would definitely recommend writing down our first two steps. A little note here, it's kind of useful to have. And our last parts here as well. So our first step in our process is to write the quadratic equation into standard form. And that's this ax squared plus bx plus c equals 0. You can think of this really as I want everything on one side of the equation and I want 0 on the other side. Now, a lot of people think that I have to get everything to the left side of the equation and the 0 has to be on the right side. That's not the case. As long as everything is on one side and 0 is on the other, all of this could be over here, and this 0 could be on the other side, whichever, doesn't matter here. Now it should be noted within this particular step that we have, this might take you a couple lines of work to do some rewrites to get things into that standard form. So get comfortable with rewriting different equations and things using all of our previously learned properties with that. Once we have everything written in standard form, this ax squared plus bx plus c equals 0, we're then going to fully factor the quadratic expression using any method that we have learned. So that could mean that we're going to be using the greatest common factor, maybe we're going to be using the special properties where we have the difference of a square, maybe we have a perfect square trinomial, maybe we need to use the AC method. All of those previously learned methods that we have are all showing up here, and we can use any of those that we would like. Sometimes we're going to use a combination of them, sometimes we're only using one. It all depends on the numbers and values that we have been given. Should also be noted here, some methods are going to be faster than others depending on what we've been given at the start of a problem, but I'd be very hesitant to say that there is one method that is always and forever going to be the fastest one whenever you're going through and solving these types of problems with factoring. Very much depends on what you've been given. So step 3 tells us we're going to use the zero product property and set each factor equal to 0. This is a little bit of an abstract one to think on because we haven't seen this up till now, but we're essentially going to have two things multiplying together, maybe three things, but at least two things multiplying together inside of sets of parentheses. We're then going to find out what would make this first set of parentheses equal to 0, what would make this second set of parentheses equal to 0. And then, in step 4, we're going to solve each factor's equation. This is going to give us our potential answers for this type of problem. And again, this is something, steps 3 and 4, we haven't seen yet, so we'll go through those in a bit more detail and some examples as well. And last but not least, we have step 5. We're going to be checking each answer by individually plugging these answers into the original equation. You don't want to plug it into the second step or the third step or the factored step because maybe something went wrong along the way with that, and we want to make sure we're checking it in the original thing that we've been given. I will also note that when we are going through and checking our answers using this, you're welcome to use your calculator to do that. That would help speed up the process. I think that's a pretty useful tool that we have at our disposal, and why not use it? So this is our overall process that we're going to be going through and using. We'll take a look at a couple examples now. Here we have our first example looking at. It's given to us in the form of x squared minus x minus 12 equals 0. So following our process that we have written down, we're going to write everything into standard form, meaning everything on one side of the equation equaling 0. If we look at this thing, well, we already have everything on one side, it already equals 0, so great. Our first step has already been taken care of for us in our problem. So great, step 1 done. Our second step tells us to fully factor the quadratic equation using any method that we have learned. And I'm looking at this left side and I'm saying, okay, does this look like anything I've seen before, or where should I start with this? I think a great place to always begin any kind of factoring process is looking to see, is there a greatest common factor between the first, middle, and last terms, or all the terms in the polynomial given to us? We don't have a greatest common factor, so all right, that's fine. We can't do anything there. We're looking to see, does this look like any type of problem that we have seen in our previous sections? And this, to me, looks like a 7.2 problem. So I'm going to factor this thing using the process that we learned in 7.2. And what we did there, we identified our b and our c values. Actually, yeah, I think it's worth writing down. It's similar to the AC method. We can write b and c down. b is -1, c is -12. And now I need to find two numbers that multiply together to give me -12 and add together to give me -1. So like we did previously, oops, it should be 2, 2 and 6, and 3 times 4. So we list all the factor pairs. We need to determine the signs for these things. They multiply together to be a negative number, meaning one is positive, one is negative. Which one's positive, which one's negative? I look to the b value to tell me the sign of the larger column here. So this right-hand column is going to be my negative numbers, left-hand is going to be positive. And again, we're looking at that because small numbers on the left, large numbers on the right. If the result should be a negative, then the larger numbers have to be negative. So which ones add together to give me -1? It's going to be this -4 and 3. Let's circle that here in a different color. And because this is the 7.2 material, we can jump right to our fully factored answer, which is having it written as x plus 3 times x minus 4. I'm just bringing down the equals 0 on the way. So we just done step 2. We fully factored the left side of this equation. We fully factored the quadratic expression specifically. Now moving on to step 3. This is where we get into some newer material. We're going to use the zero product property to set each factor equal to 0. Now for me, I always do a little bit of a rewrite with this, and the visual helps out with this. I'm going to set each of these sets of parentheses equal to 0. Because again, our zero product property says I have two things multiplying together here that equals 0. The only way that the result is 0 is if one of these things is 0 or if both of them is 0. So if my first set of parentheses is 0 and the second one is, let's say, 10 million, then the result is going to be 0. Let's say the first set of parentheses is negative 10 million, but the second parentheses is a 0. So what's the result of that going to be when they multiply together? It's going to be 0. So I want to find which x value or x values are going to make each set of parentheses 0, and that's going to tell me my final answer. So we've just split them apart here, and now we're going on into step 4, which is solving the factors equations. So I'm just going to solve this first equation like we've done previously with solving equations, and solving the second equation just like we've done previously with solving equations. Doing them one at a time, looking at the first one, I'm going to be subtracting 3 from both sides. As a result, I'm getting x is equal to negative 3. With the other one, I'm adding 4 to both sides because I'm solving for x. And I'm getting x is equal to 4. So I have my two potential answers right here. Now to check these, moving us down here a little bit, we can only check these answers one at a time. So you need to note for yourself what's the first one you're going to be checking. And I'm just going to check x equals negative 3 first. So from our original equation, I should say. Oops. Computer's glitching on me a little bit. There we go. So I write out my original equation exactly as it's been given to me. And now wherever an x value shows up in this, whether it be on the left side, whether it would be somewhere on the right side, doesn't matter. We are going to substitute in negative 3 in for x. Whenever you are doing substitution of any kind, whether it be with a number, with a variable, with an expression, with an equation, any of that, anytime you are doing substitution, always substitute inside of sets of parentheses. So we can see here where there was an x, it's now parentheses negative 3. Where there was an x, it's now parentheses negative 3. The reason we do that is that we make sure we are properly applying exponents to negative signs. If necessary, we are properly applying negative and negative signs as necessary, because if we don't include those parentheses, we might miss that. So we go through and we're simplifying this down. We have negative 3 to the second power. That's going to give us 9. A negative and a negative makes a positive, so I'm going to be adding 3 equals 0. I'm getting 12 minus 12 is equal to 0, and I'm getting 0 is equal to 0. So great. X equals negative 3 is a correct final answer, or is one of our correct answers here. Let's go through and check the other one. Because we have two potential answers, let's make sure they work. So again, just like the previous one, we're checking x is equal to negative 4. We're writing out the original equation that was given to us. And then we're substituting 4 in for x. And whenever we substitute, we always substitute inside of sets of parentheses. Simplify each side down using PEMDAS, our order of operations. Oops, make that a better 12. There we go. And I'm getting 0 is equal to 0 again, which is perfect. Both sides are the exact same, which means we have our two final answers of x equals negative 3 and x equals 4. Now I will note, if you would like to go through this the check process and make it a little bit easier, in the, where's that here? Yeah, in our second line of work, when we substituted in our values in for x, if you wanted to enter that left side of the equation, all of that into your graphing calculator, including the parentheses, exactly as it's given, you could do that, and that could get you right to your final answer there a lot easier. That's what I'm going to be doing off to the side here as we're going through our next set of examples, just to save a little bit of time. I just wanted to note this is our full process of going through and checking these answers if you wanted to show all of your steps for it. But either way, we still get our first sets of answers for number 1 as x is equal to -3 and x is equal to 4. Looking at example 2, we have the equation 10m squared minus 2m is equal to 0. Again, we're trying to look and fully factor this thing since it's already written in standard form, everything on one side equaling 0. So I'm looking at this, and it's not a trinomial. It only has 2 terms in it, so I kind of limited my options there. This thing isn't a difference of squares because this first term is not a perfect square and the second term is not a perfect square, so I can't use that. My only other option at this point in time is to really start off with doing the greatest common factor and seeing what we can do from there. So I'm looking at my first term and my second term, and I'm seeing what's the largest number that evenly divides into both. Our greatest common factor for that is going to be 2m. So if I factor a 2m out from both of these terms, what am I going to have left over? Well, the first term is going to become 5m. Second term is going to become 1. I'm going to bring down equals 0 here. Now from here, I'm looking at what's left over inside the set of parentheses, and I'm saying I can't really do anything else with that. It's not the difference of squares, it's not a trinomial, I can't do anything else from here. I fully factored this left side of the equation. Great, step 2 is done. Like we did with example 1, we now need to split this thing apart and solve each individual factor for where it's equal to 0. So again, for me, I like using these little arms or, oops, what's that here? Some little lines to help me separate it out and split these things apart. You don't have to do that if you don't want to. It's a personal thing. It helps keep it all in line for me. And now I'm solving first using I guess we're in step 4 now. I'm solving each factor equation for m. So on the first one, I have 2m. I don't want that 2 there anymore. So I'm dividing both sides by 2, and I'm getting m is equal to 0. For the other one, I'm solving for m. I'm going to get m all by itself, so I'm adding 1 to both sides. And then I want to get the m all by itself. I want to get rid of that 5, so I need to divide by 5. Meaning m is equal to 1/5. Now I did a check off to the side here using a calculator already, and these two are indeed our final answers. If you wanted to, you could go through and write everything out using methods that we did in example 1, or you can plug this into your calculator and check each of those individually in the original problem, but either way, our answers for number 2 are going to be m equals 0 and m equals 1/5. Now we're going to get into the last 2 examples, which are meant to be some kind of trickier looking ones, but still follow a similar process that we use to go through and solve these problems with factoring. So number 3, we're given something in a particularly weird form of the quantity k minus 2 raised to the second power. Now you'd be forgiven if you were thinking from here, well, I'm going to rewrite this thing as, don't write this down, just using it as an example. I'm going to write this thing down instead as k squared minus 4, because this exponent distributes through, and then that thing separates out into k minus 2, k plus 2, because this is the difference of squares, and I can solve it from there. You'd be forgiven for thinking that, because it is incorrect, but we will not be doing that. Turns out, by our properties of exponents, that if I have something raised to a power, that means whatever the base is going to multiply by itself that many times. So really what we have here is k minus 2 times k minus 2. Exponents do not distribute through the same way that a number multiplied in front or behind would multiply and distribute through. So exponents work in a completely different way. But we can see now that when we expand this thing out from its original form, we look at it and go, well, wait a minute, this thing is pretty much already factored for us. Everything's on the left-hand side equaling 0. And I have two things multiplying together in sets of parentheses. So really looking at this thing and looking at our process, step 1 kind of already done for us. Step 2 also done for us. Now I just need to set this thing, split it apart and set each of them equal to 0, which I think on this we kind of don't really have to. I'm going to get the exact same thing. And now we are effectively just solving one problem. I'm adding 2 to both sides. I'm getting k is equal to 2. And lo and behold, on the other side, I'm doing the exact same steps, and I'm getting the exact same answer. So in this case, I have, quote-unquote, 2 answers, but really, I have one single answer. And the answer is k is equal to 2. So again, kind of a weirder starting place with this one. Again, this is very much a non-conventional starting equation, at least from what we've seen up till now. But this is how it can be given to us. If you're a little unsure on going from our first step and rewriting things into the second step here, you do have the option of fully multiplying this second step out and then factoring the result from there. But I will let you know right here, right now, you're going to end up right back in this place. You factor everything again. So, taking a little bit of time, taking a little bit of patience, slowing down, and just expanding what we've been given, just to see what it looks like, can actually yield some pretty great results and save us a bunch of time with problems. The power of doing rewrites. So problems like this makes life a bit easier. A lot less we have to do then. And this brings us then to our fourth and final example, the list of the ones we have here. We are given something written out as 36x squared is equal to 121. Now looking at our process that we had written down, our first step tells us that we need to write the quadratic equation into standard form. So everything on one side of the equation equaling 0. Only way I can do that is I need to get rid of either the 36x squared from the left side, or I need to get rid of the 121 on the right hand side. Me personally, I like to keep the squared term positive if I absolutely can. And so I am going to choose to get rid of the 121 on the right side. Now I'm getting rid of that by subtracting 121, not whatever that was. So I'm subtracting 121 from both sides. It means the left side is going to become 36x squared minus 121 equal 0. So there we go. Our first step is done. Now our second step, told to fully factor the quadratic expression on the left-hand side. I'm going to make this one a little bit clearer there. There we go. So I'm fully factoring the left-hand side. I'm noticing I have only 2 terms over there. And those terms are separated by a subtraction sign. 2 terms and our subtraction sign. This thing might be the difference of squares here. Now look at the first term and I'm seeing, okay, well 36 is a perfect square. And x squared is a perfect square. So the whole first term in its entirety is a perfect square. 121, is that a perfect square? We can try taking the square root of that off the side. If you need to use a calculator for that, you're welcome to do so. But 121 is a perfect square. It's the same as saying 11 squared. So this thing is actually the difference of squares. This is going to be, therefore, a 7.4 problem. So with the difference of squares, if I can identify what the square root of the first term is, which is going to be 6x, and the square root of the second term is, which is 11, then I can write this thing out into its factored form, which is a plus b, or in this case 6x plus 11, and then a minus b, or in this case 6x minus 11 equals 0. With each of these, it doesn't matter if you do the positive one first or second. It doesn't matter if the negative one is first or second. As long as one of them is positive, one of them is a negative. It's always going to have this pattern showing up here. So, step 2, done. Fully factored this thing. Moving on to step 3, we need to use the zero product property and set each factor equal to 0. So again, I'm just splitting these things apart. 6x plus 11 equals 0, and 6x minus 11 equals 0. And then from here, step 4, I should say, solve the factors equations and get to our final answer. So for our first one, on the left side, we're subtracting 11 from both sides of this equation. We're getting 6x is equal to negative 11. And then to get x all by itself, I'm dividing both sides by 6. And getting my final answer of x is equal to negative 11 over 6 here. Looking at the other one, we're doing pretty much the opposite. At the very beginning, we're just adding 11. That gives us 6x equals 11. Dividing both sides by 6. And that gives us x is equal to 11 over 6. And again, I check these answers off to the side using a calculator, and both of these are going to work. My recommendation to you as you are going through these problems, and if you have fractions showing up somewhere in your final answer, leave your answers as fully reduced fractions, even if they're improper fractions like we have here. And the reason we don't want to convert these things into decimals is because we can see with a lot of other numbers, decimals get really, really, really gross. And where you do or don't round those, it can and will create rounding errors and might give you inaccurate numbers when you are checking them. Or if nothing else, leads you to the understandable but inaccurate assumption that both sides of the equation are slightly different and therefore it's the wrong answer, when it actually is just the case that we had a rounding error show up and that's what ended up happening. That was the result of it. So when you can, work with fractions as your final answers. They're perfectly fine, perfectly acceptable, and we actually prefer them quite a bit to decimals for final answers here. But otherwise for this one, we have our two answers of x is equal to negative 11 over 6. Apparently the fraction bar decided to go away there, or just not show up. So our first answer is x is equal to negative 11 over 6. The second answer is x is equal to 11 over 6. And there we go, example 4. So bring this back to our notes. We have our overall process that we have here and our steps for going through and solving these quadratic equations using factoring. We also have our definition of the zero product property. Again, I would recommend that you pause the video, write these down for yourself as necessary, because I think it's pretty helpful to have notes to go back and reference as you go through these types of problems. Also, scrolling this down, I'm going to give you some group problems or some extra practice problems if you wanted to give those a try. So I'd pause the video here if you'd like some practice to give these problems a shot. Again, using the same process that we had listed up above. And scrolling down here, we're going to get our answers to each of these now. I think I want to note with this, and a lot of people run away from this, is they see, well, I have 0 showing up as my potential answers for a couple of these problems. That's okay. There's nothing wrong with having 0 as part of your final answer. It's a perfectly reasonable answer, and it shows up fairly frequently as we're going through these types of problems. So there's nothing wrong with it. So since we have our processes for going through and solving quadratic equations with factoring, we have to address the big elephant in the room that shows up with equations is we're going to start having story problems showing up that are going to start having equations in them. Now, what I have here is one way and one proposed strategy that you could go through and take a look at and solve story problems. The unfortunate reality, I'm going to rip the band-aid off now, is that there is no universal strategy that works for every single story problem. It just sadly doesn't exist. I tried to give one here that I think is reasonable, or at least some things to think on and try doing when you're going through and setting up and trying to solve a story problem. I'm going to move us off to the side here, and I think this is an arguably better, maybe a bit more straightforward flow chart with this. But my recommendation is to think of story problems in two very distinct parts. So we have an overall story problem that's been given to us. Now, a lot of people think that we need to, basically, we have two different parts that I think are distinct that we need to think on with story problems. And that is the setup portion of a story problem, and that is the actually doing math portion of a story problem. Now, a lot of people, when they see something, they want to go, okay, I read through the problem once really, really quickly, and then I'm going right to doing math. But our main goal is a lot of people think, well, I've read a problem and I just want to go right to the step of doing math. I know equations, I have processes, I want to start computing and number crunching things. Maybe you're someone who you're thinking on this and going, yeah, that's what I've done. To which I would say, here's a different strategy, a different take that I would recommend we go with for these. You can use this if you would like to. You don't have to. It's 100% your call. But I'd recommend trying this if you're someone who is in the boat of, yeah, I kind of struggle with these things a little bit. I'm not entirely sure where to get started with them and how to go through them. Perhaps this would be a way to think on it instead that would be helpful. We are, instead of jumping right to doing math, going to do something in a little bit different order. From the setup, or from the start of the story problem, we're going to go to the setup first. Now, the setup includes, and don't want to take up tons of pages, or tons of parts of the page, but setup is the most important step, the most important series of steps that you're going to take in all story problems. The actual computation of doing math and all of that in our later steps, we know how to do that. We have processes for that. The setup is the part that a lot of people struggle with, understandably, because there really isn't a step-by-step guide to go through and set up a problem. So I want to list a couple things that you can do and you can use that would be very helpful, or at least I have found to be very helpful with setting up story problems for yourselves. And I'm just going to put these out in bullet points in no particular order. I would make a note of these and use them as necessary, mix and match them as necessary in different story problems. Some of these are listed on the page off to the left. Some of these aren't. Use them as you see fit. So, first one I would say, if I can get the pens working for me. Read and reread. This means if you're given a paragraph of stuff, if you're given just a single sentence of stuff, but read the problem as many times as you need to. Another one I would say is highlight important information. Now, highlighting can be any number of things. It could mean you are making bullet points, you are literally highlighting, you are underlining, you are circling, you are crossing out important information, whatever you need from that. But you want to try and figure out what's the actual useful information that this problem is giving you and what is useless. Another part that can be helpful with this, making bullet points. And the other one I would note within this is look for units. So units can generally take the form of feet, inches, gallons, miles, something like that. It's a really big giveaway with a lot of these story problems as what relevant could be useful, could be useless, is relevant, isn't, anything like that. Another couple other ones I want to throw out here for you. Drawing a picture. And I'll tell you right now, you do not need to be an artist. Just channel your inner Bob Ross a little bit and draw something, make some mistakes along the way with it, but draw something with it. When you draw a picture, this is a great opportunity also to label that picture with the necessary information that you ended up finding earlier in the problem or as part of the problem as well. All of this is to get the information down and on paper for yourself so you don't have to memorize what the problem says, which pieces of information are important, which ones aren't relevant, and where did they go in the context of the problem. Another one we can use is writing equations, actually writing and modifying equations. So maybe we're working with an area of something or the perimeter of something. We start off with the general equation with that, and then we modify that later on as we read through the problem and say, hey, the length is 3 feet longer than something else, or 2 miles less than something else, whatever it may be. We start with something and modify it accordingly. And then the last one, I've come to find this in more recent months to be a very, very useful one just to get started with a problem. Summarize it. So you're given a whole bunch of information in a problem potentially. Sometimes it's a full paragraph worth of stuff. So instead of getting bogged down in all of the little details that are given to you, trying to determine what equations you may or may not use, how am I going to draw a picture of this thing, what are important units, all of that, you can take a step back and say, hold on, let me just, with no specific details or anything, let me just summarize this problem. Summarize what's going on and do it in your own words for yourself. It shouldn't be specific. It shouldn't be 100% accurate. It's just a summary of what you've been given. And then from there, maybe you can start highlighting important information. Maybe you can then draw a picture. Maybe that helps you reread the problem a couple times. Maybe it tells you what are some important units from there. But all of these different strategies that we have right here and these different tools at our disposal are designed to help us with the setup of story problems. Oh, running out of space here. Zoom out a little bit. Once we've done all of this and we have a better idea of what's going on with the problem, what's relevant information and not, we can start generating and creating problems and equations, and then suddenly look at it and go, hey, I know how to solve this thing, and then I can actually start doing the math. Once I get to the step of doing math, I can pretty much forget about all of that. I don't need a lot of the information. I can just use the processes that I've learned up till now to actually solve what I've been given. Hence the actually just doing math portion of these problems. So as necessary, take a moment, go ahead and pause the video here if you need to. I think this is a pretty useful flowchart to write these things, or to write down for yourself, mainly because I think this is going to help you at the very least get a maybe more solid foundation of how to start approaching story problems. And we'll go through some of the examples, or some 3 examples that we have here at the very least with how to set up the problems. The actual doing math I'm going to leave to you to do on your own, but I will show you the answers at the very end of these as well. Looking at our 3 example story problems that we have here, let's go through and at least work through the setup of each of these. And from there, I'm going to let you, on your own, go ahead and do the math on them to get to your final answer or answers. I'll scroll down to the final answers that we have here at the very end of these problems, so that way you can check to see if you have the same thing. But let's take a look at number 1. Using our strategy that we had previously, we're just going to read the problem a couple times over to see what we're getting here. So we're told to find two consecutive even numbers whose product is 528. So for me, I'm seeing some buzzwords and some things that are standing out to me. I'm told the product of something. So that means that some things are going to be multiplying together. What else is standing out? Well, I'm seeing something saying two consecutive even numbers. So we got to think on what does that entail. Well, consecutive numbers are numbers like 1 and 2, 5 and 6, 10 and 11, negative 300 and negative 299, negative 47 and negative 46, and so on. Those are consecutive numbers. Well, if I have consecutive even numbers, that would be something like 6 and 8, 10 and 12, negative 14, negative 12, something like that. So you figure, well, okay, well, how am I going to get to those two numbers? Well, if I have my first number, n, how would I get to my second consecutive even number? Well, if we think to the example of 6 and 8, that second number is how many more than the first? Well, it's 2 more. So my first number, if it's going to be 6 or 10 or n, how would I get to my second one? I would take that first number and I would be adding 2 to it. Again, we think back to our examples. I have 2 and 4, 8 and 10, 12 and 14, negative 12 and negative 10. All those numbers there. So we have our first number of n. We have our second number of n plus 2, whatever that is. Okay, and now I need to find the product of those. Product tells me multiplication. So I have my first number, n. I have my second number, n plus 2, and those things are multiplying together. So I can write them out in a set of parentheses like we have right there. Now another one that I want to highlight here, because we're not done reading through this problem, buzzword of is. Is one of the buzzwords that represents an equal sign. It tells us something equals something else. So when you see that buzzword showing up in a problem, that right there can tell you, hey, there's an equal sign. That just split up my problem into essentially 2 parts. Everything to the left of it is going to be the left part of my equation, and everything to the right of it is going to be the right part of my equation. So we have our left part is, or the same as saying is equal to, 528. And now I look at this and I say, okay, does this make sense with what I've been given? Find two consecutive numbers, so I have two consecutive numbers, whose product, okay, and they're multiplying together right here, is 528. So I have two numbers multiplying together equal 528. And now I can go through and solve this thing using any methods that I've learned. I'll give you a starting step here. If I multiply everything together on the left-hand side using the distributive property, this n is going to multiply through. I'm going to get n squared plus 2n equals 528. How could we go through and solve that from there? We check the processes that we did further up that we did previously to solve it from that point. Let's take a look at number 2. Let's get the setup going with this. Number 2, we're told the area of a rectangle is 123.25 square feet. The length is 6 feet more than the width. Determine the length and the width. So let's take a step back from the problem because we have a lot going on there. We've got an overall area of something. We've got something going on about the length and the width. And we're determining 2 things here. So let's take a step back. We're going to try the summary approach with this. And this is what I mean when I say summarize a problem. And we're going to use minimal details here to do that. So I have a rectangle, and it has an area. And I know that the length is going to be longer than the width on that rectangle. And I'm trying to find both the length and the width of that rectangle. Now right there, and hearing that, not specific in any way, shape, and form, gives us a general framework to at least start writing and putting something down. So maybe we can draw a picture with that. I have a, whoops, the computer would cooperate with me. There we go. I have a rectangle. I have the length, and I have the width of this thing. We can put the area inside. We know that that's 123.25. Cool. Well, what else have we been given? Well, we've been told the area is 123.25, so that's where we have that equal sign showing up. Good. What else do we have? Well, we've been told in the second sentence the length is 6 feet more than the width. So again, the buzzword is showing up. That tells me I've got another equal sign in here. So the length is 6 feet more than the width. So if I know what the width is, I can add 6 more to that, and that's going to give me the overall length of this thing. So I'm going to move this over just a little bit so I have some space here. And now I have a bit more information about the general shape of this thing. I know what the area is. I have some more specific information about the length and width. And now I need to bring all of this together and say, well, is there any other information that could be useful within this problem? Well, I've been told that I'm finding the area of a rectangle. So what do I know is the equation for the area of a rectangle? Well, our general equation for that is area is equal to length times width. Now, can we fill in some other information into this general equation and modify it to match the problem that we've been given a bit more specifically? And yes, we can. Have we been given the area? Yeah, it's right here. So I can fill that in and modify the equation a little bit. Just making some lines here to separate this out. So I have an area of 123.25, and that's equal to, and generally we would have the length times width here. But I don't like that I have two variables on this side. I can't actually solve this for the length or the width if I have two variables on that right side. So that means I need to replace either the length or the width with a different expression that uses the other variable. And I actually have that right over here. I know the length in terms of the width, so I can substitute in that new length into this equation. So instead of having the length written as L, I could write in W plus 6. So instead of having the length in there, I can rewrite the length as W plus 6 because that's been given to me. And now I have something written in here, and now I can start solving this. We can distribute the W through and solve using our previously learned methods for going through and solving equations with our factory methods. And then we'll take a look at our last example again just to get these set up, written down for ourselves. So we're told the sail of the Black Pearl has the shape of a right triangle. One side of the sail is 6 feet longer, or 7 feet longer, I should say, than the other side, and the hypotenuse has a length of 13 feet. Find the lengths of the sides of the sail. Okay, so we have the general shape of this thing is a right triangle. Again, you don't need to be an artist, but I think having a quick visual is helpful with this. We're told one side length is 7 feet longer than the other side, and we don't know which one of those are, so we're going to leave that blank for now. And the hypotenuse has a length of 13 feet. So the hypotenuse is always going to be the side opposite the right angle. So that means that I know that this side is going to be 13 feet. Now the first part of this sentence, we're told one side of the sail is 7 feet longer than the other side. So that buzzword is showing up in here. Okay, so I've got, let's say this side length, we'll call it A. This other side length, we're going to call it B. Don't know what it is right now, but we have A and B. And we're told one side of the sail is 7 feet longer than the other side. Now this doesn't tell us inherently, is this A or is this B for the side? And so because it's leaving it fairly open and ambiguous there, it's our choice how we want to write this thing out for ourselves. So I'm going to, just for the sake of space, I'm going to say that based on what this problem is saying, the one side is B. I'm going to say B is 7 feet longer than the other side. So it's going to be the same as saying whatever the length of A is plus 7. So now, looking at this thing, we now have each side length in terms of a single variable, and we have the hypotenuse written out as a value here. We might look at this and say, okay, well, how can I make an equation out of this thing? Well, what equation do we have that tells us the side lengths of a right triangle? And that's going to be the Pythagorean theorem. Remember, the Pythagorean theorem in its general form is written out as a squared plus b squared is equal to c squared. And now we can fill this in with more specific information. We're going to leave the a squared as it has been. The b is going to be replaced with a plus 7 squared. And c is going to be replaced with 13. And now from here, we can go through and identify what our a value is going to be using our previously learned methods. And once we have our a value, we can plug that in down here and find b. So we'll let you go through and check that. I would pause the video here before we go down and see our final answers. But these are our setups for the 3 story problems that we had here. And right here we have our answers to the first, second, and third story problem. Now if you're looking at the first one and wondering, well, how can we have 22, 24, and negative 22, negative 24? We were told to find 2 consecutive even numbers. When you went through and factored this, you may have gotten 1 positive and 1 negative answer. Well, if I got 22 as my positive, it means the next consecutive even would be a positive 24. If you got negative 22, then the next consecutive even would be a negative 24. Or maybe you got negative 24 and you got negative 22. But either way, we have a pair of answers and a pair of answers here. We would need to list both of those as potential final answers to this problem. For the other ones, yeah, the numbers get a little bit gross. With that, we have some decimals showing up. Again, along the way, you're welcome to use your calculator to help you out with those number calculations if necessary. But we should be getting 8.5 feet and 14.5 feet. And then for problem 3, we should be getting 5 feet and 12 feet. Those are answers. And the last part, we're wrapping up here with our 7.6 material.